In this video, we'll look at the product and quotient of functions. I use the same points as on the sum and difference of functions video. I suggest you watch that first. Though this isn't much harder. We're going to find f times g at x, which is just, we don't have to write this, but that's the same as f at x times g at x. And so how do we do that? Again, if you've watched the previous video on sum and difference of functions, you know you just look at the points that overlap with x values. So for example, f at x has a -2 and g at x has a -2 for x. Since they overlap at -2, that's one of the points we use. And how do we get the y value? Just times 3 times 6, 18. -1, 5 has no corresponding x value of -1 in g at x, drop it. But 0, 8 has a match in g of x, and so we take that x value, 0, and we take the y values, times them together. 8 times 5 is 40. 1, -3 has no corresponding x of 1 in g at x, so we drop that point. But 2, -4 has a corresponding x value of 2 here, so 2 is going to be one of the places they overlap. What's -4 times 6? -24. 4, 9 in g at x has no match in f at x for its x value. That's it. Those are all our points. How do you do f divided by g at x? Well, just like the previous one, you can think of it as f at x over g at x, but you can just go right to the list of points. And we already know which x's overlap, -2, 0, and 2. I can even start those off. I already checked in the previous question to see where the overlap was. I know it's going to be at x of -2, I'm just setting it up here, and x of 0, and x of 2. And so, what's f at x divided by g at x at -2? Let's look. -2 is the x. Take the y values. What's 3 divided by 6? That's 3 over 6, which reduces to 1/2. At the zeros, you get f at x divided by g at x, which is 8 over 5. And for the 2's, you get -4 over 6, which reduces to -2 over 3. And that's it. We found the f times g at x of these points and the f divided by g at x of these points. Let's move on to question 2. This time we've got two functions. Sine x is f at x, and g at x is a parabola, x squared minus 4. Put a little line here to separate that. So f times g at x, how do we write that? We literally just write f at x, the function sine x, times, and I'll just use a bracket for times, g at x, which is x squared minus 4. There isn't really a point of expanding this or rainbowing it in. I would just sub in, now that we have the function, what's f times g at x at 3? We just take our multiplied function, f times g at x, and sub in 3. We get the sine of 3 times 3 squared minus 4, which equals, and I'll leave sine 3 for a moment, and just simplify in the brackets here. 3 squared is 9, minus 4 is 5. And now I'm going to use my calculator. Make sure your calculator is in radians. And there's a little r, so mine is. What's the sine of 3 equals? And times by 5. I'm going to round here to 3 decimals. I get 0.706. And so I have the f times g at x value when I'm working with the f times g at x equation. I put a little underline here to make sure, this is, I always check on tests to make sure you rounded correctly to 3 decimals. What about f divided by g at x? Well, it's just like we did on this question here. You just take f at x over g at x. So this equation is just going to be sine of x over x squared minus 4. And again, there isn't much point of working with that. I would just sub right in. That's the same as when we're subbing in a value of 3 to find f divided by g at 3. That's just our combined function, f divided by g at x, but evaluating it when x equals 3. And I'll simplify the bottom again. First, the sine 3 on top, and on the bottom 9 take away 5. Oh, sorry, this should be a 4. How did I get a 5 there? I don't know, magically was thinking of the answer and wrote down a 5. So, sorry, 9 take away 4 is 5. Just like last time, it has to be the same value. It's 3 squared minus 4 again. And that's going to be approximate again. I know I'm going to round that sine 3. Sine 3 equals divided by 5. And I get approximately 0.028. And now I've evaluated at that point. Well, when we're talking about the domain of this multiplied function, we just want to look at where they overlap. What's the domain of sine x? The domain of any sine function is x is an element of R. What's the domain of a parabola? X squared minus 4. Well, that parabola, like all parabolas, has domain of x is an element of R. And so where do they overlap? The domain of f times g at x is, they overlap everywhere, every possible x. So we have x is an element of R as their overlap. But what about the domain of f divided by g at x? Well, I should write here, this was f at x, this was g at x. Let's state that again. The f at x domain is x is an element of R. And the g of x's domain is x is an element of R. That is, f divided by g at x also has a domain of where they overlap, with one extra addition. G at x cannot equal 0. That's because now g at x is in the denominator, and whatever makes this denominator 0 is not allowed. Dividing by 0 is undefined. So where would g at x equal 0? We have to check. X squared minus 4 cannot equal 0. You could do difference of squares to factor this, or you could add 4 both sides and get x squared cannot equal 4. And then take the plus or minus square root of both sides and see that x cannot equal plus or minus 2. Do you see that if you subbed in 2 or negative 2 into this equation, you'd be dividing by 0? That has to be excluded from its domain. Therefore, the domain of f divided by g at x is domain equals x is an element of R. Everything is allowed except for these x's. X cannot equal negative 2, comma 2, because you'd be dividing by 0. And we've done it. We found the product and quotient of functions. We did it with points in question 1, looking at the product and the quotient of functions. And we did it in question 2. We looked at the product and the quotient of functions, and we looked at their domain.